Okay, so let's start. Say and spell your name so our editor doesn't mess it up.
My name is Thomas Yun, Thomas, last name Yun.
Y-U-N. And what is your title, Thomas?
Staff Engineer, Thermal Management Group.
Excellent. Here at UTRC,
Yes.
right?
Yes.
Yeah, yeah. Terrific. So Thomas, give us a little bit of your background. How long have you been at UTRC and what brought you here?
So I've been in UTRC in Thermal Management Group for 3.5 years. So I like the like fundamental like academic and also like industry oriented research in the like United Technology Research Center.
Excellent, excellent. So tell us about your award. What was the award you won and what did you win it for?
Yes. So this work is about disruptive technology development, focusing on additive manufacturing techniques. So this work combines three different projects. One is that we build first ever polymer-based multifunctional heat exchanger for aerospace application. Second is high temperature heat exchanger, also for aerospace application that far exceeds the performance of conventionally built heat exchanger. And third, we focus on developing the additive manufacturing inputs that can build high quality heat exchangers. So at the end of that project, we were able to build a conformal heat exchanger that has very industry best quality for heat exchanger performance.
Excellent, excellent. So, all right. So, in layman's terms, because I don't know a heat exchanger from a something else, but so explain to me what was the problem you had before that this now solves.
Okay, so heat exchanger, when we built it additive, like people can think by doing additive, like they can implement the innovative feature design to improve heat transfer and also getting a better flow for heat exchanger performance improvement. However, when it comes to the additive manufacturing, there are two important factors. One is surface roughness, and the other is the geometry discrepancy that people don't think. And the impact of not understanding the surface roughness and geometry discrepancy, actually it impacts a lot on heat exchanger performance. So my part of work is to analytically and experimentally characterize the impact of surface roughness and geometry discrepancy, and by using that built with our physics-based model for heat exchanger design tools, we were able to design the advanced heat exchanger.
Excellent, excellent. How large is the team and how long has the project been going on?
So there are like 3-4 different projects, actually more than that. I was luckily involved in all three. So each team, 5 to 10. So one of the example for polymer-based heat exchanger development, we had 5 or 6 groups in a week fully working on these projects, and with all 5 focusing to advance the heat exchanger performance for polymer-based heat exchanger. So at that week, we build 5 heat exchanger. Every day we test, discuss the performance, and redesign it, and the build overnight. So next day morning, we came back and test the new heat exchanger and like discuss the performance and like redesign it, all grouped together, and build another one. So during that 1 week, we built 5 different polymer-based heat exchanger. We were able to enhance the performance, heat transfer performance by 30%, and reduce the pressure drop by 70%. So that was great teamwork in this project.
That's fantastic. 30% over 1 week. That's incredible. So how proud is the team to be winning this award?
Very, very proud. Like at the beginning of the project, we were very excited, and when we first built the sample, now we see the sample like of the features are not what is expected. We put it on the test, like performance is not as what is expected, but we try to focus on the fundamentals, why this is not performing as we expected. The surface roughness and geometry discrepancy was the key, and we focused to improve those and try to get a high quality additive manufactured manufacturing inputs to build a high quality heat exchanger.
Excellent, excellent. So I want you to say, we won, is it Outstanding Achievement Award?
Yes.
Is that what you won? Okay. So we won the Outstanding Achievement Award for, and just give us the title of that.
Yeah.
But right here to me.
Okay. So we won the outstanding achievement for the work for disruptive heat exchanger technology development, mainly focusing on additive manufacturing.
Excellent, excellent. Was there anything you thought we were going to talk about that we didn't? Anything you wanted to say that I didn't give you the chance to say?
I think I said it.
You think you got it? All right. Thomas, great job, buddy. Thank you
Thank
so
you.
much. You're off.